All right, I wanted to make a short video just kind of reviewing all the concepts that our quiz is over tomorrow for you. So this first question number 1 through 3 asks us to write each number in scientific notation. So remember, scientific notation, I need my first number to be greater than 1 but less than 10. So I'm going to rewrite this as 4.87. So now my number is greater than 1 but less than 10. But I need to figure out how many times I moved that decimal. So the decimal was originally here, and I moved it over 1, 2. So I'm going to multiply this by 10 to the second power. This number, remember this number right here, tells me how many times I need to move the decimal. If it's positive, I'm going to move it to the right. If it's negative, I need to move it to the left. And that's when we go back to standard notation, okay? So let's try again. I have the number 5,875,000. So in scientific notation, that is 5 point, larger than 1 but less than 10. And I can't drop any of these other digits, but I don't need the zeros. I don't have to rewrite those. Times 10 to some power. Now let's see. My original decimal is here, and I'm moving it right here. So I'm actually going to move it 1, 2, 3, 4, 5, 6 times. Times 10 to the 6th power. All right? My last example, 0.0035. Let's see. I need a number greater than 1 but less than 10, so that would be 3.5. My decimal is originally here, and I need to move it here, and I'm moving it back. 1, 2, 3. So that's to the left. -3. Okay? So that's a quick review on some scientific notation. Next, let's do some simplifying using order of operations, okay? I need to remember order of operations, parentheses, exponents, and then multiplication or division in the order that it comes, like the order that it appears, and then lastly, addition or subtraction, okay? So if I look at problem number 4, I have to do this first, the 8 times 2. So 75 minus, well, 8 times 2 is 16. So 75 minus 16, I'm doing this off to the left. We need to borrow. 15 minus 6 is 9. 6 minus 1 is 5. So 75 minus 16 is 59. And there's my answer. Okay? Let's do that again. 48 plus 16 divided by 4. Order of operations says to do the division first. 16 divided by 4 is 4. 48 plus 4 is 52. All right. Let's see. Let's do a couple of more. Right here I have an interesting problem. 64 minus 8 divided by 2. So I have to take care of this piece first, that divide by 2. All right, so let's see. 8 divided by 2 is 4. So on the numerator I have 64 minus 4. And then I can go ahead and simplify this right here, this 2 times 3. And 2 times 3 is 6. Now I'm looking back at my numerator. 64 minus 4 is 60 over 6. And I can reduce that. I can actually simplify that fraction if I divide the top and the bottom both by 6. So that equals 10. 60 divided by 6 is 10. Okay? My second example, 14 plus 18 divided by 6. So I need to do this first. So 4 plus, let's see, 18 divided by 6 is 3. And then I also have a multiplication problem right here. 4 times 8. Well, 4 times 8 is 32. Now I can do the addition in the order it appears. 4 plus 3 is 7, plus 32 equals 39. Okay, I believe I have one last example here. All right, this is interesting. Let's see. So I have to take care of inside the parenthesis first. Division. 10 divided by 5 is 2. So let's rewrite this whole problem. 36 divided by 14 minus 2 times 3. Okay, so now if I look inside my brackets, I have a subtraction and a multiplication. I have to take care of the multiplication first. 36 divided by bracket 14 minus, let's see, 2 times 3 is 6. Okay, now I can take care of this parenthesis or this bracket. Let's see, so that is 14 minus 6 is 8. So I have 36 divided by 8. And you know what, really that's not going to come out nice and evenly for you. I'm just going to write it as a fraction of 36 over 8. I could actually reduce that, dividing by 2, and get 18 over 4, which when I divide by 2 again, equals 9 over 2. A lot of you probably would put this in your calculator, 36 divided by 8, and come up with 4.5, and that's also fine. Okay, that's also fine. All right, number 9 says, which numbers are divisible by 5? Let's see, well I know for a number to be divisible by 5, it must end in a 0. Numbers that are divisible by 5 ends in 0 or 5. So I'm just going to circle the numbers that end in a 0 or a 5. Excellent. The next one says, which numbers are divisible by 10? Well, I know if it is a number divisible by 10, it ends in a 0. So I'm just going to circle the numbers that end in 0. Which numbers are divisible by 2? Numbers that are divisible by 2, they end in a 2, a 4, a 6, an 8, or a 0. We call them even numbers. Okay, so let's see. This is divisible by 2, and this is divisible by 2. Which numbers are divisible by 3? Well, numbers that are divisible by 3, the sum of the digits are divisible by 3. That's what that means. So let's look at that. Let's see, the sum of the digits. So if I take this number, that's the same thing as 1 plus 2 plus 6, which equals 9, and 9 is divisible by 3, so this number is, so the number 126 is divisible by 3. Okay? So we'll just give that a smiley face, that's divisible by 3. What about this number right here? 3 plus 7 plus 4. 374, that adds up to 14. That is not divisible by 3, so no. All right, let's look at this. 931, that's 9 plus 3 plus 1. That adds up to 13. Is 13 divisible by 3? No, it is not. And our last number, 726, 7 plus 2 plus 6, that equals 15. Is 15 divisible by 3? Yes, it is. Okay? So the two numbers here that are divisible by 3 are the 126 and the 726. Which numbers are divisible by 6? Which numbers are divisible by 6? Let's see. If it's divisible by 6, it has to be divisible by 2, which means that it ends in an even number, and it has to be divisible by 3. So let's first of all just cross off any numbers that are not even. So that's not going to be possible. Now these we have to see if they're divisible by 3. So 1 plus 8 equals 9. This number, 180, is divisible by 3. And it's also divisible by 2 because it's even, so this is good. What about 702? Let's see, 7 plus 2 equals 9. 9 is divisible by 3. This number is also good. And 1 plus 8 equals 9. 9 is divisible by 3, so this is also good. Okay? Numbers that are divisible by 9, same thing. The sum of the digits add up to a number that is divisible by 9. Okay, so let's add up these digits again. So the number 5,436, that's 5 plus 4 plus 3 plus 6, that equals 18. Is 18 divisible by 9? It sure is. So this one is good. All right. What about the number 871? 8 plus 7 plus 1. That equals 16. Is 16 divisible by 9? No, it is not. Okay. What about the number 947? That's 9 plus 4 plus 7. That adds up to 20. Is 20 divisible by 9? No, it is not. So the only number here that is divisible by 9 is 5,436. All right. We're also going to talk about prime numbers. Which numbers are prime? Prime numbers only have 2 factors, 1 and itself. So 2 is only divisible by 1 and 2. 5 is only divisible by 1 and 5. I know 15 is divisible by 3 and 5, so that's not prime. 21 or 29 has no other factors but 1 or 29. 31 has no other factors but 1 and 31. 51 is divisible by 3 because 5 plus 1 is 6. So that's divisible by 3. Let's look at 87. That's 8 plus 7 equals 15. That is also divisible by 3, so it's not prime. I have another set of numbers. Which numbers here are prime? Well, let's see. I know that 81 is the same thing as 9 squared, or 9 times 9. So that's not prime. Let's see. 92. Well, it's an even number. This is even. No even number other than 2 can be prime. So that's a big no. So let's go ahead and look. Do we have any other even numbers? No, we don't. Do we have any numbers that end in a 5 or a 0? We sure do. We can cross those off. Let's see. 7 plus 1, 71. 7 plus 1 is 8. 8 is not divisible by 3, so this number is probably prime. We're going to have to check it, but it's probably prime. What about the number 61? 6 plus 1 adds up to 71. This number is also probably prime. 8 and 3. 8 plus 3 is 11. And then 47. 4 plus 7 is also 11. So we have 4 potential numbers that could be prime. Now when I say check them, you know, think of the odd numbers that we talked about. Try 13. Does 13 times 7? You know, what is 13 times 7? It's 91. So really these are golden ones. These numbers are prime. Now if you don't remember prime numbers, you can actually look at your prime number chart. Okay? You can go back to your prime number chart. Now we're writing as a product of primes. So this is where I'm going to make a factor tree. So I have the number 64, and I have to divide up this number with primes. Well, I know 64 is the same thing as 8 times 8, but neither one of those are prime. So let's see. I can break up the number 8 by multiplying it, or 8 is the same thing as 2 times 4. So I can do that with both of them, 2 times 4. I'm going to circle my prime numbers. 2 is prime. So now I just have to break down the 4. And that is also the same thing as 2 times 2. Ow! because these are also prime. All right, so now I need to rewrite this as a product of primes. So I have 6 2's there. I can write it as 2 times 2 times 2 times 2 times 2 times 2, or I can write it as 2 to the 6th power. All right, almost finished. We're going to write the number 72 as a product of primes. So factor tree again. 72, that's the same thing as 8 times 9. 8 is the same thing as 2 times 4. 2 times 2. 9 is the same thing as 3 times 3. So if I were to rewrite this, I have 2 times 2 times 2 times 3 times 3. Or I could write it as 2 to the 1, 2, 3 power times 3 to the 1, 2 second power. Okay? What number is equal to the square root of 16? What number is equal to the square root of 16? Well, that's the same thing as 4 times 4. 16. 4 times 4 equals 16. So the square root of 16 is 4. The square root of 64 is 8. The square root of 81 is 9. The last two, what number lies between, the square root of 79 lies between what two whole numbers? Remember we made a number line and we said, well, let's see. If this is the whole number 5 and the square root of 25 share the same space. 6 and the square root of 36 share the same space. 7 and the square root of 49 share the same space. 8 and the square root of 64 share the same space. 9 and the square root of 81 share the same space. And it just so happens that the square root of 79 is going to fall right in between there. So the square root of 79 is in between the numbers 8 and 9. Let's look at this one below. The square root of 29 lies between what two numbers? Well, the square root of 29 is about right here, and so that lies between the two numbers 5 and 6. All right.